In this episode of Overview Biostatistics, I continue to this flow again, begin at the conclusion. So from here, to be more clear, we will look at the abstract of a research. By begin of the conclusions, I put it here. That means in a research, for example, I take a paper from the New England Journal of Medicine, a study conducted in Thailand, to know if the newly invented vaccinations can prevent HIV/AIDS or not. So begin at the conclusions. That means once we read the paper, we take a look at the abstract first, and at the abstract we will focus in here. If not interesting, we will proceed to the next paper. We focus at the conclusion. Okay, so here is what I mean by begin at the conclusion. Now take a closer look at this. The main findings, the main conclusions. So here, this vaccine regimen may reduce risk of infection. So this is the main finding. This is what I mean by begin here. Then what next? What roles are you? If you are a researcher, you need to be frank with your audience by have a clear magnitude of effect. This one for them to judge if the conclusion is okay, or if you are a consumer, you need to look for where is the magnitude of effect. It's just here. So the second component of this, I will put this one in blue color. Where is this one? It is here. Okay. The vaccine efficacy was 31.2%. That means about 1/3 being prevented by this vaccine. So this is what was found in the study sample of 16,000 or 8,000 per group, the group being vaccinated and the placebo group. So this is called statistic that obtained from the sample. So I will put this again in this color. So by what I said, the magnitude of effect, there are two components. The first one is called statistics. Obtained from the sample. Okay. And the second component is here. It's called, this is the first component, this is the second component. This is called statistical inference. That means it used what was found in the sample to apply to inference to the larger population from n, from small n to the capital N. Okay, so this is statistical inference. Now, in these components of statistics that being reported in a paper, there are also two components within it. The first one is what we call the confidence interval. CI stands for confidence interval. This is called parameter estimation. Parameter means that quantity, that magnitude that would be found in the population, or the P, population, the S, sample statistics. This is parameter estimation. Confidence interval. And the second one, the P value, P, probability, P value, is the second component of statistical inference. Is called test hypothesis or hypothesis testing. Okay, so these are the evidence that we need to look at, to judge, to investigate if it is valid, because this will be used for the conclusion. Now, in more details, we will discuss on how bias could occur in that paper. Or here, it quantify the random error for what? For judgment. Now take a look at this. We will not discuss for now about the bias, but just a random error. For judgment means what? Means that in a sample of 16,000, we found that vaccine can prevent about 1/3 of the populations to be infected with HIV if they vaccinated. But even this group of the researcher repeat the study again in the same area. Of course, they will do another random sampling or randomization, not in the same individual for sure. If they repeat again, it will not be 31 for sure. It will be differ due to variability, due to a chance to obtain another sample, which is differ from the groups that being studied already. It will not be the same. It will be varied. Now, this is to quantify how likely in the larger populations that efficacy would be, or if they repeat the study again and again for 100 times, about 95% or 95 times, it could be varied from 1 to 52, for example. So that means we quantify random error for judgment. Then we judge. We, if we are the researcher, judge and then conclude it. That means may reduce risk. If we are a consumer, we read the paper. If the researcher claim that is can rather than may, can reduce risk, is it valid, for example? So if we imagine some vaccine can prevent about 1%, we will not take that vaccine for sure, because it's less useful. But if that vaccine can prevent about 52%, we may, it probably good. For example, this HIV is very serious disease, so we may take. So if the confidence interval says something by looking at the lower limit and say another thing looking at the upper limit of the interval, that means we are not sure, or sometimes we call inconclusive. But the tendency tend to prevent that, so that is may reduce risk. So this is quantified for judgment. The researcher judge and then make a message or conclusion. Or if the reader or the audience want to investigate further, they can use their own judgment by look at this. That means quantify error for judgment. This is the first component. The second component is the hypothesis testing. What does it mean here? It means that there is a hypothesis that usually if we have two groups to compare, if the two groups vaccinated and non-vaccinated have the same infection rate, that means vaccine has no efficacy. This is the null hypothesis, no efficacy. And the alternative would be there is efficacy. So that's some easy example. So that means the p-value is to quantify the probability of how large, how likely of obtaining these findings even if there is no efficacy. So seems to be very difficult, confusing. Then the people usually interpret it as significance if the p-value is small, or non-significant if large. How small is small? There is a cut point called 0.05. If less than that, it's interpreted as significance. If not less than 0.05, it's non-significance. So that's the p-value, the second component of that magnitude. We will continue in details later after we have some explorations about what's behind this. So in this episode, I just want you to understand about where statistics play roles in research. You see, it's nothing. It just quantify the random error for judgment. It will be wrong here if you think statistics prove something by looking at the p-value and say this is significance, looking at only the p-value, because it's less than 0.05, it will be significant. If you say this vaccine is significantly reduce or prevent the HIV infection, it will mislead the society that this vaccine work well. But if we look at the magnitude of effect, not the magnitude of chance, magnitude of effect is how large the prevention portion or the efficacy. Say, in the sample we found about 1/3 being prevented. But in the population, it could be only 1% prevented, or up to 52% prevented. That means inconclusive, if we frankly say. But the tendency is protective, so that is the basis of this conclusion. Just that for now. We will continue in the next episode about the remaining steps in details of the research where statistics can play a role.